was really having trouble with the trials. I just didn't have the energy. Luckily, someone told me about the Physics Friends Network. I don't know what's wrong.
Tony, I'm thinking it's your kinetic energy.
Why didn't I think of that? The Physics Friends Network is live, one-on-one, and 24 hours a day.
You'll speak with a trained Physics Friends Network physicist.
I'm seeing it now. You need more gravitational potential energy.
Why sit there wondering? Call today and get a free consultation for only $5.95 a minute. That's free for only $5.95 a minute.
Thanks, Physics Friends Network. I couldn't have done it without you. Sports figures, put your brain in the game.
This thing here, well, this is a skateboard. And that thing over there, that thing's called the vert, as in vertical. And that guy back there is Tony Hawk, 12-time world champion in the vert. And the only boarder to ever do this, a 900-degree spin, 2.5 revolutions. Say no more, he's the man. Tony, what are some of the tricks that you guys do in the vert?
We do tricks like kickflips, varials, 540s, grinds, nose slides.
So how do you judge a grind?
Mostly you're just on your consistency and your difficulty, your height and speed, and what kind of combinations you can throw together.
It looks like you guys use some very serious energy to get through one of those routines.
Yeah, we get pretty tired, especially when we're going one event to the next.
So if you've been doing like a 3-day event, how do you find energy to go on and win?
I don't know, sometimes you gotta dig deep to find it.
Well, what if I told you that all the energy you needed was right over here? The stairs.
No way.
Way, come on. I'm telling you, climbing the stairs will give you all the energy you need in the vert.
I want to see you prove it.
All right. Energy is one of the coolest things in physics. It's a very special quantity. What makes it so special? Well, think about this. In the whole universe, energy can never be created or destroyed. You can't make it, and you can't destroy it. Pretty wild, right? Climbing the stairs is a lot of work. It seems like it would use up a lot of energy. But how can climbing the stairs actually give you energy? Phew, I sure did a lot of work to get this bowling ball up here. It may not seem like it, but this ball is now actually full of energy. I can't see it or feel it, but it's there. Now, the kind of energy that's in there is called gravitational potential energy. You see, gravity is pulling it down, so it has the potential to go down. You see, it's moving. So now, it has a different kind of energy, kinetic energy. Because we're up here off the ground, we have gravitational potential energy. That's why it's sometimes called the energy of position.
Gravitational
Well, you know, we can make this a little bit easier by using GPE for gravitational potential energy and KE for kinetic energy.
Cool.
Yeah. Anything that's moving has kinetic energy. In fact, the faster you're moving, the more kinetic energy you have. That's what kinetic means, moving. So if you're on your board, you've got kinetic energy. Wow.
All right, so what you're saying is that when I'm rolling on my board, I have kinetic energy.
Right.
And you said that energy can neither be created nor destroyed.
Right. But he stopped him. He didn't have kinetic energy anymore. The energy was destroyed.
Good point. Good point.
Well?
You can think of energy like this. Let's say this money is energy. Well, money can be transferred, right? Jackie, can I borrow a few bucks? Thanks. Well, the money's gone, but it hasn't been destroyed. Now my friend has it. Now, let's say she runs into someone else she owes money to.
Hey,
Hey.
I really need that money that you owe me.
Oh, yeah, sure. Hey, man. Looks like you have that money you owe me.
Oh, yeah, sure.
You see? the money wasn't destroyed. It just got passed along from one person to the next.
Hey, Jackie, sorry, I really need to borrow a couple more bucks. Thanks.
See, that's just like energy. It can never be created or destroyed, but it can be transferred. Hey, you know, I'm gonna need that back tomorrow. Now, when you jumped on the board, you had,
Kinetic energy, because I was moving.
and then,
Some of his kinetic energy was transferred to me.
voila, energy is transferred. Now, not only can energy be transferred, but it can be converted from one form to another. Ooh, magic. Hey, have you got that money that you owe me?
Yeah.
I think there's a little more.
Right. Good. And that's 40. Thanks a lot.
No problem. Well, I got my money back, just in a different form. You see, that's just like energy, because energy can be transferred, or you can convert its form. I think I'll go do my laundry. A money conversion machine? An energy conversion machine. Watch what happens to Tony Hawk's energy. Tony starts out at the top with gravitational potential energy. As he comes down the vert, the GPE gets converted to kinetic energy. His kinetic energy carries him up the other side, but as he goes up, it's being converted back to GPE. You see, the energy just keeps getting converted from one form to another. GPE to KE, KE to GPE, GPE to KE, KE to GPE. Whoa, I'm getting kind of dizzy.
You said that energy could never be created or destroyed.
But when you go back and forth in the vert, eventually you will stop.
What happens to the energy when you stop?
Yeah, what's up with that?
Well, let's do a little experiment and find out. Let's see what happens when we drop a bowling ball down the vert. Cool. The energy is conserved because energy can't be created or destroyed. Hey, what happened? There wasn't a force to stop the ball, so where'd the energy go? Actually, there was a force. As the ball was rolling down the surface of the half pipe, there was friction between the ball and the surface. That friction converts the energy of the ball into another kind of energy, thermal energy. Ow. Heat. Fire has a lot of energy, right? Well, fire is just heat. Lots of it. And heat is a form of energy. Geez, I hope you guys like these well done. Both the surface of the ball and the half pipe got a little hotter as the ball rolled. The energy wasn't destroyed, it was transferred to heat. Ooh.
So now the energy is heat in the tail of my board.
Exactly, and some of it's gone into the asphalt. And some of it's been converted to sound, too. Sound is a form of energy as well. Ooh, you okay?
So what happens when you stop all at once like that?
Well, a couple of things happen. Some of the collision is turned into heat, and some to sound. When you kiss the ground like that, the Earth actually moves a little bit as your kinetic energy gets passed to it.
No way.
Way.
Wow.
Those are some pretty hot wheels.
My wheels are hotter now, but then they cool off, so what happens to the energy then?
Oh, well, the temperature of the wheels.
We interrupt our program for this news just in. A group calling itself Citizens Against Skateboarding has suggested that skateboards might be a possible source of global warming. Let's go to Sal Masekela for more.
This is a rough call for skateboarders, and many are crying low blow. What we're talking about is simply this. When the wheels of the skateboards and the vert surfaces heat up, that heat energy actually goes into the air and heats up the Earth's atmosphere a tiny amount. It gives heat energy to the air. Energy can't be created or destroyed. It always has to go somewhere. The heat from a skateboard isn't that much, but what the CAS claims is that if you add all the skateboards on the planet, we've got a problem. This is Sal Masakela from the X-Trials.
Sal, thank you very much. The Department of Environmental Protection is considering the accusations. We'll have more as this story unfolds.
All that energy can't be destroyed, it just keeps getting transferred.
Right, but because you can't store up the heat energy, it gets lost. So what are some ways that you can increase your energy in the vert?
Well, I bend my knees and I straighten them through the transition that propels me upward.
Like energy.
Right.
Okay.
What I still don't understand is how I got the gravitational potential energy in the first place.
Okay, well, you climbed up the stairs, right?
Right.
All right, in physics, we call that work. Work is the process of applying force over distance. Down here on the ground, this weight doesn't have any energy. It just sits there. But when I lift it, I'm doing work. I'm transferring my energy to the weight. I'm moving it. This weight now has gravitational potential energy, but I'm not doing any more work on it. I'm applying a force to hold it up. Now that may seem like work, but it's not. Work is only when something's moving. We can see it in the formula for work. Work equals force times distance. Ugh. Work has to be a force over a distance. Lifting weights is work. Holding weights is just force. Ugh. When you push off on your board, you're applying a force over a distance, right? Work is a transference of energy. Woo! You are giving yourself gravitational potential energy. Yes. Now, here's the cool thing. The GPE you have is equal to the amount of work you did to get up here and the KE you'll have at the bottom of the vert. Now, we can prove this with an equation that looks like this. GPE equals weight times height. Okay, Tony, let's figure it out. Now, first we need mass. How much do you weigh?
150 pounds.
Well, that's about 700 newtons. And what's our height?
About 3 meters.
Okay. 700 newtons times 3 meters, and we have 2,100 joules of gravitational potential energy standing right here. And that tells us that you use 2,100 joules of energy just to get up here. And when you reach the bottom of the vert, you're gonna have 2,100 joules of kinetic energy. And we can figure that out too. In a formula, it looks like this. KE equals 1/2 mass times velocity squared. At 150 pounds, Tony's mass is equivalent to 70 kilograms. So all we need is his velocity. Okay, Tony. 17 miles per hour, which converts to roughly 7.7 meters per second. So we end up with KE equals 1/2 70 kilograms times 7.7 meters per second squared. And we get 2,000 joules. The gravitational potential energy has converted to kinetic energy, except for a little loss in air friction.
Nothing lost, nothing gained.
Exactly.
Okay, so you work to climb the stairs, and that gives you gravitational potential energy.
And that energy changes into kinetic energy when you go down the vert.
And that energy gets you up the other side, and it's converted back to GPE.
And then the whole thing is started all over again.
But if energy is neither gained nor lost, then where did Tony Hawk get the energy to go up the stairs in the first place?
Yeah.
Tony used the energy in his muscles to climb the stairs. He was converting chemical potential energy inside his body. He got the chemical potential energy at breakfast this morning when he ate cereal, toast, and juice. Your body stores the energy from food as chemical potential energy. The cereal, toast, and juice got their energy from the sun. Plants take energy from the sun and convert it to chemical potential energy by the process of photosynthesis. Just like the vert, energy can never be created or destroyed. It just keeps getting passed along from one object and form to another. Well, that's it. We'd like to thank everyone who helped us out today. Tony Hawk and our students, Meredith and Jasante, Max, Edgar, Ellis, and of course the X-Trials for helping us out on ESPN Sports Figures Boarding School. You know what? I think I've transferred all my energy. Oh,